here yesterday, you should find the notes in Google Classroom and watch them, listen, write them down. I need a calculator. All right, today we are talking about arc length and area of a sector. And we want to be able to find the length of an arc of a circle, and we want to be able to find the area of a section or sector of a circle. And I wrote here, arc length is part of the whole circumference of a circle. And what we have here, a little picture that you're going to want to draw. We have an angle, which is what is called a central angle, because it goes through the center of a circle. So that's a central angle there, theta. And we have this portion, it is a part of the whole circumference of the circle. So this is just a little piece of the whole circle, all right? And what we're trying to do is figure out how long is this piece of the circle? What is the length of that edge, okay? We use S to represent the arc length. I don't know why they chose S, it's kind of random. But we have a couple of different ways that we can set this up. And I like to start this way. Yeah. I like to start by understanding that we have a piece of a whole thing. And if you have a little piece of a whole thing, then all it is a fraction, all right? So if I want to figure out the arc length S, it is a part out of the total circumference. Do we have a formula for circumference? Yeah, circumference equals 2 pi r. So S is just a part of the whole 2 pi r, part of the whole circumference, okay? It has to be proportional to, well, what else do we have? This angle theta, maybe it's like 120 degrees, all right? So maybe it has a measure on there. Well, if it was theta, has some angle measure like 120 degrees, that's again part of what's the whole then. If we're in degrees, how many degrees would be the entire rotation? 360, all right? So 360 degrees. Now, here is a nice little setup for when theta is in degrees. Then it's just a fraction of 360. And then we have our fraction of the length of the circle over the total circumference. So it's really just this great proportion. And we can set it up that way. And then how do you solve for S? Cross multiply. Yeah. This is totally easy. So you can basically multiply that to the other side, right? I like setting up like this because you can solve for anything you want to in this form. Now, this is great if we are in degrees. You can see that these would have to match. They have to both be degrees in order to use this setup. But maybe theta is given in radians, so I want to do this one because this one's really interesting. So if I want to know the length of this arc, so that's S, out of the total circumference, so out of the total 2 pi r, it would be equivalent to our theta in radians. How many radians get all the way around the circle?
Oh, wait,
6.28. So when Mary said, where's pi? 180, right? Okay. So if 1 pi is the top, the other half would be the second pi. So how many pi's? 2 pi, yeah. And 2 pi is 6.28. Okay. 2 times 3.14. Okay. And so this is when we're in radians, and that's very important. Now watch what happens here, because this is very interesting. How do you know if you're in radians? No degree symbol. Very good. All right. So watch what happens. We're going to solve for s. I want to get s by itself. So I'm going to take this denominator, and we're going to multiply it to the other side. Cross multiply, if you will. So I get s alone. That's going to be, let's see, theta times 2 times pi times r on top. And then I have a 2 times pi on the bottom. What happens? Yeah, they cancel out. The 2's cancel out, the pi's reduce, and I'm left with s equals, now we normally write it this way, r theta. The radius times theta, but this only works when you're in radians, okay? So I love this because that's a super simple thing. So arc length is s equals r theta, radius times your angle measure, as long as you're in radians. Isn't that amazing how it cleans up? Yeah. That's why math is cool, okay? This one doesn't clean up, but it's fine as well. The nice thing is, you know, you're going to forget this formula tomorrow, all right? But this is a proportion. It's a part of the whole thing. And you can always get back to it, right? Like you can always say, hey, this is just a piece of the circumference. So you have a part over a total. And I can compare that to whatever other information I have. And that works all the time. So it's very, very cool. So here, for examples, we want to find the length of the intercepted arc. That is what this S is, the length of the intercepted arc. Given the angle measures and radius. Give your answers in terms of pi and then rounded to the nearest tenth. So here we have an angle measure of 5 pi over 6. Is that in radians or degrees? How do you know it's radians? No degree symbol. Thank you for saying that. It is not because there's a pi there. But we have our lovely little formula, S equals R times theta. So our radius is 3 feet, and our theta is 5 pi over 6. I'm going to multiply straight across. 3 times 5 is 15 pi. Over 1 times 6 is 6, so that's 15 pi over 6 feet. And then 15 and 6 can reduce.
2 and 5.
Yeah, we can divide top and bottom by 3, so 15 divided by 3 is 5, and 6 divided by 3 is 2. So this is your exact answer. It is 5 pi over 2 feet long. And if you plug that into your calculator, 5 pi, wowza, that was the wrong button. 5 pi divided by 2 is approximately 7.9 feet long.
Do we need to fully go down to the approximate on most of these, or do we just want this direction?
I'm not sure what the directions say in Delta Math, so it's probably this.
Okay.
It's probably simplify.
If it isn't, I'm just assuming you hate us.
All right. Do you need another one of those, or are you good with that?
We're good.
Okay, let's look down at number 5. What's different about 5, 6, 7, and 8?
They have degrees.
They have degrees. So you have an option here. You can do it a couple of different ways. Do you want to set it up with the proportion this way?
Sure. I want to see what.
I think that's a great way to do it. We're given degrees here. So I'm trying to find my arc length over 2 pi r equals my theta in degrees out of 360 degrees. So there's my setup. I'm just going to plug in what I know. So S over 2 times pi times my radius of 8.4 equals, what's my theta angle? 15 over 360 degrees. And then all I have to do, I want S by itself, so all of this stuff underneath it right now is being divided, so we're just going to multiply it to the other side. S equals 15 times 2 times pi times 8.4 over 360. Everything goes on top, 360 is on the bottom. And this one has a decimal in it, so decimal answers are fine. If it begins with a decimal, it can end with a decimal. That's the rule. 15 times 2 times pi times 8.4 And then, so that's the numerator divided by 360. We get 2.2, and the units are meters, 2.2 meters in length. You don't have to convert to radians. Yeah. I think it's easier. I mean, but yeah. Oh, good question. Sure. Pi is in blue above the exponent, so you do second and then that. Yeah, good question. All right. Do you need another one of those, or are you okay?
I think we're good.
Oh, actually, we're going to do number 9. Number 9 says, the central angle theta in a circle. So, drawing a picture here, we have a circle. A central angle goes through the center of a circle. The circle has a radius of 6 meters. And there's a central angle theta that has an intercepted arc of 10 meters. So there's the arc length that we know, the arc length there is like 10 meters. All right? So I don't know how far that goes, but that's what they're saying. The arc length is 10 meters, and we want to find the measure of theta. So we're trying to figure out, hey, what is that central angle? Is it 3 degrees? Is it 100 degrees? What is it? In radians and degrees. Okay. So we could do the same one, but I'm going to use S equals R theta. Why am I going to use S equals R theta? I have the radius and I have the arc length, so here we go. So my arc length is 10 meters. My radius was 6 meters, and I want to solve for theta. And so I need to do what? Divide by 6. So I get theta equals 5/3. Okay, what unit is that in? Radians. Yeah, 5/3 radians. So theta equals 5/3 radians. You notice it doesn't have a pi in it? Radians technically is unitless. It doesn't have any units, and you can see that here because we had 10 meters and 6 meters. What happens to the meters? They cancel out. Yeah, so radians actually turns out to be a unitless measure, which is kind of cool. It absorbs whatever measure you use, which is really kind of interesting. So how do we convert this to degrees? Theta degrees. Let's see, where's pi, ladies and gentlemen? 180. So I have 5/3 radians. I'm going to multiply by, I want degrees, 180 degrees over pi radians as my conversion factor. Pi is the value of 180 degrees, so I want degrees on top. Oh, I can do a little bit of reducing here. 3 goes into 3 once, and 3 goes into 180 60 times, right?
Yeah.
And then 5 times 60 is 300 degrees over pi. 300 over pi degrees. Well, that's kind of weird. Let's type that in. 300 divided by, wow, 300 divided by pi is 95.5 degrees. All right. Hey, look it, I almost drew that correctly. How did I know it was like that? Yeah, so 1 radian would have been 6 meters. 2 would have been 12. So somewhere between 1 and 2 radians. And that, okay, cool, very good. Okay, turn the page. Oh, all right. So let's look down at area of sectors. Now, again, kind of a cool way to derive things. Are you guys with me here?
Yeah.
All right. So once again, radians turns out to be totally rad. We have, again, a circle, and inside that circle we have some central angle. I don't know maybe what it is. Some central angle. And what we're trying to figure out is I want to know the area of this section of the circle. I don't want to know the total area. I want to know a piece of the area. And so once again, if I want to find the area of the sector, it is part of the whole area. So what is the formula for the area of the whole circle? Pi radius squared. Hey, you learned something in geometry. Rad. Okay. So it's pi radius squared. That's the whole area. But again, do we want the whole area? We're trying to find a piece of the area. So I want to know, hey, what's the area of the sector? The area of the sector is what I'm trying to find, the area of the shaded region, if you will, out of the total area, which we know is pi r squared. All right, well that is, yeah. So what if our angle is in degrees? So it'd be theta out of how many total degrees? Yeah, 360 degrees. Good. So again, we set up this proportion, and again, you can cross multiply from there with whatever you got. That's if we're in degrees, but we're not in degrees. So let's say that we want to find the area of that sector, that pink sector. It's a part of the total area of our circle, which is pi r squared. And then now we're in radians again. So if theta's in radians, how many radians go all the way around? 2 pi. 2 pi radians. 1 pi gets you halfway. 2 pi gets you all the way. All right. All right. So once again, this side cleans up super rad. So we're going to cross multiply. The area of our sector is theta times pi times r squared over 2 pi. And what reduces? The pi's reduce, and we get, we could do theta r squared over 2 if you want to. Perfect. I think I probably 1/2 theta r squared would be the same thing. But let's see how this works. Number 12, which setup do you want to do? The setup on the left or the left? Why did you choose left? Because it's degrees. Okay. So I want to find the area of the shaded sector. So the area of the sector over 2 times, oh, sorry, not 2, pi r squared. What's our radius? Equals our angle measure, which is 74 degrees out of 360 degrees. It's part out of the total, a piece of the whole thing. And then how do we get the area of the sector by itself? Multiply, cross multiply. So the area of the sector, in my calculator, 74 times pi times 4 squared, all divided by 360. Let's see, 74 times pi times 4 squared. And then all divided by 360, and I'm getting 10.3. So the area of that little sector is 10.3. Ooh, units. What are the units? Squared centimeters. How do you know they're squared? Right, yeah, right here when you plug in your radius is 4 centimeters, and you square that. That's square in the centimeters. So we do get centimeters squared as well. Centimeters times centimeters is centimeters squared. All right. What do you want to do for number 14?
Right.
The right side. All right. So for the right side, because why? No degree symbol, so it must be radians. Good, good, good. All right, so we are using our little formula. Area of the sector is theta times radius squared over 2. Ooh, interesting. That is why sometimes it's better to do 1/2 theta r squared is another way to write that. Why did I do that?
You have 2 levels.
Yeah, so you don't have 2 levels of fractions. Yeah, good. All right, so the 1/2, and then our theta is 2 pi over 3, and then our radius was 7 kilometers squared. Type it in the calculator, but this one's all fractions. So, well, that's just 49. 49 times 2, 98. And then on the bottom, 2 times 3 is 6. Could you just use your calculator? Yeah, I don't really care, but sometimes it's good, you know. All right, 98 times pi divided by 6, we get 51 point something, 3? 51.3, approximately. What are the units? Kilometers squared, yeah. All right, let's look at number 16, and then I think we're done. The area of a sector of a circle. So again, ladies and gentlemen, draw a picture. We have a circle, and the area of some sector with a central angle of 240 degrees. So here's my initial side. It's an angle of 240 degrees. That's somewhere out there, 240 degrees. And what is this number? What is this 134 feet squared? That's the area of the sector, right? And we want to figure out R. Find the radius of the circle. That's what we're trying to figure out. So what should we do? Which formula do you want to use? The left side, yeah. So, hi.
I have a permission slip to go on the fine arts field trip tomorrow.
There you go. All right. So the left side, the area of the sector. So my area of the sector is going to go on top, and that was 134 feet squared over pi times radius squared, and I don't know what the radius is, and we're trying to figure that out, so that's fine. And then our angle was 240 degrees out of a total of 360 degrees. Those zeros cross out. And can I also reduce the 24 and the 36? All right, so I'm going to clean that up just a little bit to make my life a little bit easier. 134 over pi r squared equals, I'm going to divide those by 12, so 2/3. All right, now how do you solve? Cross multiply. In this case, I'm going to cross multiply. 134 times 3 is beyond me, so that's 402 equals 2 pi radius squared. And so what do you want to do? Just divide by 2? Divide by 2 pi, very good. We're going to divide away the 2 pi. So the 2's cancel out and the pi's cancel out. Let's see. You have to be careful here. 402 divided by the whole 2 pi. What did I do there? I used parentheses. Okay, so you... Yes, yeah. So you do have to be really, really careful when you're dividing multiple items there. So we get 63.98 equals radius squared, and then what? Square root both sides. So second square root, second answer, ladies and gentlemen, in Delta Math, do not do the square root of 63.98. Okay? It will get the wrong answer every time. Because in Delta Math, the math rule is you do not round until the end. So you'll notice I pulled in the answer. The answer button is way down here in blue, and it pulls the previous answer. You can highlight it and suck it in if you want to, yeah. So 7.998, I guess that's pretty much 8 for the radius there. Crazy. All right. Do you have questions for me? Was that pretty easy? Oh boy, circular motion. All right. Let me get you.